Anyways,
This call is now being recorded.
next, आज हमने पढ़ना है algebraic fractions. Okay, I just gave you a question that was also algebraic fraction. You had an algebraic expression in the numerator, and then you have an algebraic expression in the denominator, and the question was to simplify. But in that question where you just have one fraction, what you do is basically you factorize the numerator, you factorize the denominator, cancel out the common factors, and whatever left is the simplified fraction of this one. But this algebraic fraction, what we are going to do here, we will be having multiple fractions of algebra. A, B, C, D, E, and F are any random algebraic expressions, and we will be adding or subtracting them. So this is what we are going to learn today. Normally, if you have 2 by 3 plus 7 by 4, this is not algebra. These are not algebraic fractions. These are just numerical fractions where you have to add them. So whenever you have to add or subtract the numeric fractions, you know you have to take the LCM of the denominators. So in this case, the LCM would be 12. Just a quick recap of how you deal with the numbers. So 3 times what is 12? 4. So you put 4 there, multiply it with the numerator of the same fraction, plus 4 times what is 12? 3. So you put 3 here, multiply it with the numerator of the same fraction. There you go. So this is how you add or subtract the numerical fractions. And you can simplify it further. Over here. Yes.
Why 4 into 2?
Sorry? Ask again.
Where it's 4 into 2, won't it be 4 into 3?
No. You multiply it with the numerator of the fraction. 3 times 4 is 12, and whatever this is, this will be multiplied with the numerator of the fraction. So that's what we did over here. So we checked what we had 4 in the denominator. So we checked like 4 times what is 12. So we know 4 times 3 is 12. So 3 multiplied by the numerator of the same fraction, which is 7. Okay.
Excuse me, sir.
Yes.
Sir, is this plus minus between the fractions?
Yeah, I have written plus minus because it can be plus or it can be minus. Whatever it is, you will do the respective operation accordingly. But this is the procedure, even if it is plus or minus between the two fractions.
Okay.
Okay, I'm just trying to explain the procedure of the numeric fractions here. Just a quick recap. But this is not what we will be doing today. We shall be dealing with completely algebraic fractions, but we will be having the same two operations, addition or subtraction. Okay, now before we jump onto that, the first thing is, this is an important note. Whenever you get a question, the main command word would be write down as a single fraction. So these are the command words for the for these kinds of questions. Write down as a single fraction, or maybe simplify. Okay. Now the important note is, whenever you get these kinds of questions, before solving the question, you need to make sure that you always factorize the denominator. So always factorize the denominators before solving the question. You have multiple fractions. So before solving the question, check all the denominators. If they're already in the factor form, that's fine. If they're not in the factor form, make sure you do factorize them. Forget about the numerators. I'm not talking about numerators here. I'm focusing on the word denominators. So do not factorize the numerators, factorize the denominators only. Okay, so this is the first thing which you have to do. The next thing is about the cases. Now I'm going to elaborate the case and then we will do the questions as well. I want you to write down these cases on your notebooks on one page, because after we are done with the cases, then we will move on to the questions. So when we are doing the question, I would like you to keep the cases in front of you so that you can check that particular fraction or question matches with which case, so that we can apply the technique accordingly. Okay, now we will have something over something, and the first case, something over something. So this is the one of the cases where you have exactly same denominator. Now A here, I'm using capital A, capital B, or capital C. I'll be using these terms. Now these A, B, or C can be any expressions. X squared plus 7. This is an A can be equal to x squared plus 7. So I'm not writing down any expression here. So I'm just defining a variable for a random expression. So if you have, the point here is, if you have exactly same denominator in both the fractions after you have factorized it, okay, so the LCM will always be the same expression. Okay, the LCM would be exactly same expression. Now how would you solve the upper part here? You put down the numerators as it is and simply add them. The way you do with the numeric fractions, you have exactly same case for the numeric fractions. If you have exactly same denominators, you don't need to take LCM. 5 come down as it is, like over here we are saying A will come down as it is, the LCM, and you simply add the numerators. So that's what we are doing here. Simply add the numerators without changing anything. So 3 plus 7, that's what we will be taking. 10 by 5 would be the answer. So this is how you, this is the first case. Is this clear? Any question in the first case?
No, sir.
Okay, now moving on towards the second case, case number 2. Case number 2 is, after you have factorized the denominator and you realize that you have two different denominators. They're totally different denominators. So when you have totally different denominators, so LCM would be the product of both denominators. You're not going to actually multiply them. You will keep it written in the form of product. You will not going to expand the denominators after taking an LCM. You will keep it factor in the factor form like this, A into B. For example, if the denominator of the first one is x plus 5 and the denominator of the second fraction is x minus 3, now you can see there are clearly two different denominators. So the LCM would be x plus 5 into x minus 3. Now this is what I'm trying to explain here. And you will keep them in the product form. Do not expand this. Do not multiply it. Okay, so leave it in the factor form. Okay, so this is how you will be taking an LCM. Now, what are we going to do in the upper part here, in the numerator of this solution? Okay, now this is, focus here. You are not supposed to cancel them out physically, just do it in your head, or you can put your finger on it. A will be cancelled out with A. Just do it in your head. Do not cross them out physically like this. No, don't do it like this, okay? So just put your fingers on it and thinking of that A will be cancelled out with A. So I have highlighted to think that A is cancelled out with A. So what am I left with in the denominator? What is left in the denominator of the LCM? B. This B, whatever is left with, will be multiplied with the numerator of this fraction. Actually, let me just give them a different name. Numerator 1 and then numerator 2. Okay, so B would be multiplied with the numerator 1. So we have a positive sign between the two fractions. We'll put the positive. So we are done with the first fraction. Now moving on to the second fraction. You will follow the same procedure. Do not cross out. Just simply think this B will be cancelled out with the B. Do not cross it out actually, okay? Just I'm highlighting it to help your thinking that this B has been cancelled out with this B. I'm not actually crossing them out. Then what am I left with in the denominator of the LCM? A. Now this A, whatever is left behind, will be multiplied with the numerator of the second fraction. So A times numerator 2. So this is how you will be doing. Got it? So let me just give you another general example. Now these are general examples. I'm not using a proper algebraic expressions here. So for example, if you have a numerator 1 over a plus numerator 2 over b plus numerator 3 over c. Okay, now this is the same case. Okay, now we have three different denominators. So the LCM would be a, b, c, the product form. Do not multiply them. Okay, now when dealing with the first fraction, I'm not doing it now. I explained you up here. I would like you to tell me what will be the first term.
Sir, it will be a multiplied by n, the numerator 2 and numerator 3.
No, I'm dealing with the first fraction, which is numerator 1.
Numerator 1
B.
multiplied by b multiplied by c.
Excellent. Okay, so think of this, that this denominator is cancelled out with this denominator. Do not cross them out actually. What are you left with in the denominator of the LCM?
B and c.
B and C. This B and C will be multiplied with the numerator of the first one, which is numerator 1. This is the first term. Now, what is the second term now? Think. What will be the second term? Follow the exactly same procedure.
A into C into N2 square.
Excellent. A into C into the numerator 2. Shabash. Very good. All right. Now the third one. Okay. Now those who couldn't understand the second one, look, B will be cancelled out with B. Now, I'm not actually cancelling them out. I'm just doing it in my head. So what I'm left with A and C in the denominator of the LCM. So this A and C will be multiplied with the numerator of the second fraction. Now moving on to the third one. Follow the same procedure. What will be the
A
third
multiplied by B multiplied by third numerator.
Shabash. That's good. Okay. Now A into B into the numerator number 3. Okay, now when I asked earlier, one student told me A into the numerator 3. I knew where she was coming from. That is the reason I gave you this example where we have 3 fractions. Okay, now this one up here, this example, the first example looks like we have actually cross multiplied A into n to the power, oh sorry, numerator number 2. Okay, A into the numerator number 2 and B into the numerator number 1. This looks like that, but it is not the case. What is actually going on? I have explained you that. Do not think that we are cross multiplying. This may apply when you have just 2 fractions. Yeah, you can use this idea, but you need to understand the proper procedure in the background. So when you have 3 fractions, how would you do the cross multiply? A multiplied by the numerator 3? Nope. The process is the denominator of the first one cancels out with the denominator of the LCM, whatever factor it cancels out with, and then whatever is left in the LCM, B and C, will be multiplied with the numerator of the same fraction. I hope it's clear. Case number 2 clear?
Yes, sir.
All right.
Sir,
That's
it's just like the case number 1 that we have to make the denominator same, and to make the denominator same,
no.
we have to
No,
multiply
no,
the
no, 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 no,
that.
no, no. Don't think of that we have to make the denominator same. I never said I'm changing A into B or B into C. No. Just understand this process. This is totally different. Okay? Because, for example, if you have one denominator as x plus 5, another denominator as x minus 3, how can you even make x plus 5 as x minus 3? You can never do that. You're not changing the question. I told you a process. I hope you remember that process now. It's a simple process. Okay? Now moving on to case number 3, which is the second last case. Now numerator 1 over a, for example, a to the power 5 plus numerator number 2 over a to the power 3. Now when you have, understand the concept here, when you have same denominators, but with different powers. For example, one of them is 2x plus 3 whole squared, and another one is 2x plus 3 whole cube. So one denominator is 2x plus 3 whole square, another denominator is 2x plus 3 whole cube. This is the idea I'm trying to explain over here. So whenever you have this case, where you have same denominators, but with different powers, so the one with the highest power will come down as an LCM. The one with the highest power will come down as an LCM. Got it?
So sir, we will ignore the other one.
Um, no, we're not ignoring. Basically, A3 gets included in this one. A3 is also over here. For example, if I try splitting this up, A into A into A into A into, how many are these? Yeah, 5. So we have 5 A's, which satisfies this. We have 3 A's, which also satisfies this. Okay? So the one with the highest power will come down as an LCM. So this is the case 3. You can put it down in words on the side that when same denominators but different powers, then the one with the highest power come down as an LCM. So we use exactly same process which was used up here. So A5 will be cancelled out with A5. If everything is cancelled out, what are we actually left with in the LCM?
The numerator.
A3.
No. In the denominator of the LCM.
A3.
In the denominator of the LCM, I'm not even moving to the second fraction yet. The first fraction, we had A5 over here, and then I have A5 as an LCM. So this A5 cancelled out with this A5, the highlighted part. So what am I left with here in the denominator?
Nothing.
Sir, nothing. Only
So
one.
nothing. Yes, 1. What am I left with?
1.
So this 1 will be actually multiplied with the numerator 1, or you even if you don't multiply 1, that won't make a difference because 1 times anything is the same. So numerator 1 will come down as it is. Plus, okay, now we have 3 A's over here. How many A's will be cancelled out from the LCM?
3 A's, and we will be left with A2.
Yeah, we'll be left with A2. So A2 times the numerator 2. Got it?
Yes, sir.
सर अगर हम छोटी पावर वाला न्यूमरेटर डिनोमिनेटर इस्तेमाल करते हैं तो क्या हमारा आंसर गलत हो जाएगा?
हाँ, आपका आंसर गलत आ जाएगा। फिर आपका
LCM Sir, can I say that it is like the multiplication of denominators, something like that?
Nope.
Or is that quite different from this?
But multiplication totally gets different. If you multiply A5 with A3, following the rules of indices, this is actually a to the power 8. Okay?
No, sir. Like, if we suppose that instead of A5 there's 12 and instead of A3 there is some other number, so we have to make that can be written as 12 by multiplying by some other number. So we have to multiply that entire fraction. So is it like that?
Let's just deal with the question and then see where your question exactly fits in. Let's just deal with the proper question, okay? So after the last case, I'll jump to the proper questions, where the proper examples of the Cambridge examination. Then we will see where your question exactly fits in, okay? If it leaves any ambiguity, even then we can come back to the case 3. Got it?
Yes, sir.
Okay, now the case 4 is basically, well, there are actually 3 cases. Case 4 is basically the mixture of all the 3 cases. Now, for example, numerator 1 over a squared plus numerator 2 over ab plus numerator 3 over c. Now, if you look here, we have all the 3 cases. When you focus on just a's, so which one should come? The one with the highest power, because I have a squared and then I have a. Which one should come down as an LCM?
A square.
A square, excellent. So we will have a square as an LCM. And then after that, when we have different denominators, they come down as a product form. So we have B, and then we have C. Got it? Even if I have the denominator of the third fraction as BC, so the case 1 applies. When we have same denominator, we just write it down once. Look at the case 1. This was the case 1. We had A over here, we had A over here, so we just wrote it once. Okay? Any question?
No, sir.
Okay, now these were the cases I tried explaining. Now let's just jump to the question, like the proper question, and see if we can use the cases. I want you to put down the cases in front of you while we are at it. Okay, now the first example here, now simplify. Now definitely you can see these are the fractions. You can see the variables over here, but luckily the denominators are not algebraic, they are numeric. So you will solve them exactly in a way, the way you solve the numeric fractions. So you will be actually taking the LCM of 3, 9, and 18, which would be, you can start off with 2, 3. There you go. So this is the LCM is 18 in this case. Now 3 times what is 18? Now I'm dealing with the first fraction.
6 times.
3 times 6. Now 6 will be multiplied with the numerator of the same fraction, which is x. Plus 9 times what is 18?
2.
We multiplied with the numerator of the same fraction, which is 5x, minus 18 times what is 18? 1. 1 times the numerator of the same fraction, which is 5x. So 6x plus 10x minus 5x over 18. All are x's, so you can dissolve them. So 6 plus 10 is 16, minus 5 is 11. So 11x over 18 is the simplified form. Got it? So this was simple. Okay, now let's just move on to the proper algebraic fraction. Okay, now look at this one. What case is this? Look at the denominators. First of all, can we factorize any of the denominators over here?
No.
No, we cannot. So that's fine. We are good to go. If we are able to factorize the denominator, then first we will factorize them. But in this case, we are not able to factorize. So that's fine. We'll just straight away look into the cases. Now, this one matches with which case?
Sir, case 2.
Why?
So because there is 2x plus t and we can't multiply them, so we will write them in the bracket with.
Case 2 was
after
very
that.
good. Case 2 was when we have 2 different denominators. So the LCM for this one would be 2x plus 3 into x minus 3. So I'm going to keep it written in the product form. I'm not going to expand it, okay? Now just imagine in your head, 2x plus 3 will be cancelled out with 2x plus 3. This 2x plus 3 will be completely cancelled out with this
So
one. What am I
sir,
left
we will write 4 and then x minus 3 in the bracket and then plus minus then minus 2.
Step by step. Hold on. I'm teaching everybody here. Okay, so 2x plus 3 cancelled out with 2x plus 3. What are we left with in the denominator of the LCM?
X minus 3.
X minus 3. Excellent to those students who are getting it actually. I'm really sorry. I didn't mean to shun you. I'm actually teaching everybody, so we have to take everyone together. So 4 times this x minus 3 times the numerator of the same fraction. So 4 times x minus 3. All right, then we have a negative sign here. Okay, now we have to be very careful whenever we have a negative sign.
2.
Okay, now I'm going to erase this highlighted part. You don't have to highlight it when you are actually doing it. You can just put the fingers on x minus 3 and x minus 3 and check what are you left with in the denominator of the LCM. 2x plus 3 in this case. Now this will be multiplied with the 2 of the same fraction. So 2 times 2x plus 3. That's it. The main job is done. Now all you have to do is simplify. Okay, 4x minus 12 minus 4x minus 6 over 2x plus 3 x minus 3. Okay, now 4x minus 4x, this cancels out. Minus 12 and minus 6, this will give you minus 18 over 2x plus 3 times x minus 3. Keep it in the factor form because that's the simplified form. This is your final answer, minus 18 over 2x plus 3 into x minus 3. There you go, boom, 3 marks. Easy? So I see many students, they lose marks in these kinds of questions. Now there is no way you should be losing marks in these kinds of questions. All right, now this looks very simple. This is very easy. I'm going to do one more question for you. Okay, now this one matches with which case?
Case 2.
All right,
Case
this is a
4.
mixture of case
Case 4.
1.
Case 4.
This is case 4, which is actually the mixture of case 1, which by which we can say we have same things, and the mixture of case 2 as well. We have different denominators. So what would be the LCM in this case?
So the biggest denominator,
C and D.
biggest power.
D, that's it. So C1, this is a different one, D1. That's it. So C and D is the LCM over here. Got it?
So won't we write square?
No. We will write square on what? C or D?
नहीं सर, 2c है ना, और 2c तो होल स्क्वायर नहीं बनेगा.
Okay, now look here. Now, when I have numerator, okay, I'm going to take it back to the cases. Okay, now look at the first case here. I have A over here and I have A over here as well. I didn't take an LCM as A square. When you have repeated denominators, you just write them once. You do not multiply them. I'm not multiplying them, okay? So that is why I explained you the cases. If it was just multiplication, I would have simply told you to multiply the denominators. No, this is case 1, which was basically when you have the same denominator, you put it down once. You see, I gave the numerical example as well. So when you have same denominator, just put it down once, 5. That comes down as it is. Got it? So if you look at this one, so we have C over here and we have C over here. So same. So that one comes down as C. We have a different denominator, so that will be written as a product of it. So D, and this one is D as well, as same. So this will, I will just write it down once. So C and D. This is the LCM. Is this clear to everybody?
Sir, are we going to write C and D separately in brackets or together like the written in the third fraction?
It's same. Okay, even if you write with the brackets or not, there's just single term of each factor, doesn't matter. Okay, now first fraction. Tell me the first term over here. What should I write up here? Cancel out the denominators and see what is left, multiply it with the numerator of that fraction and give me the answer.
1d.
Sir, D into 1 into CD.
1 into D, that's it. So this will just leave me with D. Okay, because C cancels out with C and I am left with D over here, will be multiplied with 1, which is the numerator of the fraction. So I'll be left with D. D into 1 is D. Okay, now we have the plus sign here. I'm going to put the plus sign. I'm moving on to the second fraction. Now, what is the answer for this one?
C into 1c.
C into 1, which is actually C. All right, now I'll put the minus sign here because I have a minus sign over here. All right, now we have CD. What am I left with?
Bracket C minus D.
Excellent. Now, many students will just simply write down this one as it is C minus D, which is wrong. Whenever you have a negative sign, always use brackets. Okay? Why? Because if you use brackets, then you will end up with D plus C minus C when you open the brackets, and this minus is plus D. If you do not use brackets, you see that D plus C minus D, where d is actually positive. So whenever you have a minus sign outside, it's always safe to use brackets. Okay, the denominator stays as it is as an LCM. So plus c minus c cancels out. So I'm
2D.
left 2 times d over cd. What is the final answer?
2 over C.
2 over c. Excellent. I can cancel them out because these are factors over here. 2 and d are being multiplied. But if it was 2 plus d over cd, that would have been the final answer. I cannot cancel these two d's out. Okay. Remember, we can only cancel out the factors. 2 plus d, like they're not factors. Factors are like when something is being multiplied. Okay, which is in this case. So 2 over c is the final answer. Okay, enough of me solving the questions. Now I would give you the question and I will expect you to write it down in the simplest form. All right, there you go. Write it as a single fraction in its simplest form. So we have a number here as well. Wherever you have number, just take an LCM the way you take for the LCM. And the algebraic one, follow the cases which I just explained. Whenever you have a number in the denominator as a factor, now look at the fraction in the middle. You have 2 into x. Now 2 is over there as a factor. So whenever you have a number in the denominator as a factor, deal with it the way you do the normal numeric fractions. So one thing is for sure that 2 is coming down as an LCM because we have 2 and 2. The LCM of 2 and 2 would be 2. What else?
X.
X. Excellent. Okay, now what is the first term from the first one?
Sir, will you multiply x?
Sorry, what were you asking?
Sir, will you multiply the 2 with x? The first one.
No, what was the procedure? Think of this X. This will be cancelled out with what? From the LCM. This X will be cancelled out with
X.
X. What are we left with?
2.
2. This 2 will be multiplied with the numerator of the same fraction, which is 2. So 2 times 2 is 4. So this is the first term here. All right, now what is the second term here?
1.
Excellent, 1. What is the third term here?
1x.
1x, which is just x. Okay, final answer. Final answer.
5/2.
You just made a mistake, which I told you a few minutes
5
ago.
plus X over 2X.
5 plus x over 2x. Beta, you cannot cancel out this x with this one. Okay, you can only cancel out the factors. If it would have been 5x over 2x, now look, in the denominator we have factors. 2 is being multiplied with x. In the numerator we also have factors like 5 is being multiplied with x. Now you can easily cancel out the x's here. But when you have like this now, 5 plus x over 2x, then you cannot cancel out this x with x. Okay, they are not factors. So the final answer is 5 plus x over 2x. Okay, one more question. There you go, to this one. Now I'm not assisting you in any manner. Whoever is done, they can tell me the answer. Let's see who can do first. It should be done by now.
So I've done it.
Give me the answer.
X minus 7 over x plus 2 in the bracket and x minus 1 in the bracket.
Sir,
Excellent.
I got the same answer.
You got the same answer, then it means this is correct. Okay, now let's just see for those who couldn't do it or those who are struggling. Okay, now look, we have two different denominators. Now this one is the case 2, and we know we cannot factorize them further. So we are good to go. So we'll just simply jump to the case 2 where we write down the denominators as a product. Okay, now I'll think in my head the denominator of the first fraction, which is x plus 2, will be cancelled out with this x plus 2. I'm not actually cancelling them out. Then I'm left with x minus 1 from the LCM, which will be multiplied with the numerator of this same fraction, which is 3 times x minus 1. Okay, then the minus sign here. Now moving on to the second fraction, we have x minus 1, which will be cancelled out with x minus 1. And I'm left with x plus 2 from the LCM, which will be multiplied with the numerator of the same fraction, which is 2. So it will be 2 times x plus 2. All right, now I'm going to expand the numerator. So 3 times x is 3x, minus 3 times 1 is 3. Minus 2 times x is minus 2x, minus 2 times 2 is minus 4 over x plus 2 times x minus 1. Okay, 3x minus 2x, now dissolve the like terms, it will give you x, minus 3 minus 4 will give you minus 7, and you're good to go. Oops, x minus 1, this is the answer. Excellent. Okay, now this one again, question number 27. 4 marks, piece of cake. You can easily get 4 or 5 marks, but like you get the same kind of question in paper 2 and you get the same kind of question in paper 4. Collectively, like this particular thing makes about 7 to 8 marks. So yeah, you're securing 7 to 8 marks knowing just by just knowing the 3 cases and practicing them.
Sir, I have a question related to this question.
Yeah, go on.
Sir, x plus 1 numerator और this is the denominator, तो वो हम cancel out नहीं कर सकते.
किसको कैंसिल आउट करना है आपने, x को और x को?
नहीं सर, दूसरी क्वेश्चन वाले x plus 1 के साथ, क्योंकि वो भी x plus 1 है और इस तरफ भी x plus 1 है.
No. We have a minus sign here. If we had a multiplication sign here, then we can cancel these two out. Good question. Okay? We cannot cancel them out. Whenever we have a plus or minus sign, and if we see something can be cancelled out, we will not. Okay? Because that's against the rules. If you have the multiplication sign between the two fractions, then yes, you can cancel them out. But not in this case. Good question.
So I've done.
You got the same answer?
Yes, sir.
Or you can rewrite it down as 1 minus 3x. Write down the positive term first. So plus 1 is first, and then minus 3x is second. So this is how you do it. Any
Sir,
question?
हमने x whole square क्यों दिया?
Because x plus 5 cancels out with x plus 5. You're left with x plus 1. Then this x plus 1 will be multiplied with this x plus 1. So that is actually x plus 1 whole square. Then I applied the identity here. So a squared, which is x squared, plus 2a into b means 2 into x into 1. So that will give you actually 2x. And then plus b squared in 1 square. So that is actually 1. Okay? Got it?
So I have a question.
Yeah, go on.
Sir, can we write x plus 1 before x plus 5 in the bracket in the denominator? Or do we have to
2 times
write it
3
as it is?
is, tell me what is 2 times 3?
6.
And what is 3 times 2?
So, sir, it doesn't matter that if we write x plus 1 before x plus 5 or after it.
Yeah, that's a good question as well. Now, this thing is called commutative property. Like this commutative property is applicable for multiplication and for addition. Like you see here, when you swap the places, the answer is not affected. The same goes for the addition as well. You do 2 plus 3 and you do 3 plus 2, the answer stays the same in both cases. So commutative property, this is known as commutative property. So that doesn't matter which one you write first, okay? Okay, now the time is almost there. One last question, but I'm trying to look for the one which is a little bit trickier, and then I will let you go. Just a minute, hold on. This was question 37, I'll keep that in mind. If I don't find any trickier, then I'll leave you with the same question. Okay, while practicing, do not do the question which asks you to solve, because solve will always involve the equation, like the equality. We haven't reached there yet, so you can leave them for now. I'm trying to look for a question where you have to factorize the denominator first and then look for the cases. I haven't come across a question yet. Let me just look for. Dua, if you want to leave, you may leave. The time is there, but I'm just giving you one last question to do, and then you can leave. Sorry, ma'am. Okay, I actually cannot find a question here. What's the issue? I hope you have practiced all these questions. Look, there are very good questions of factorization, simplification of single fractions. So I hope you have done all of these. Very good questions for practice. You have this worksheet. I would like you to do. All right, I'm scrolling back to question number 37. I couldn't find one. So I'll leave you with the same question. Actually, do this one, question number 59. Then you are good to go. Still on it?
Sir Saad?
Anybody who's done it?
Sir, I've done
Share the answer, please.
1 over x minus 3 in bracket and x plus 1 in bracket.
Okay, now, anybody else?
Sir, I got 6x plus 9 over x minus 3 bracket x plus 1 bracket.
Just a minute. 6x plus 9. That's what you got? Okay, now
Yes,
let's
sir.
just do it. Okay. Now let's just do it. Okay, now LCM would be x minus 3 into x plus 1. All right, now for the first one, x minus 3 will be cancelled out with x minus 3. I'll be left with x plus 1 and multiplied with x plus 3. So x plus 1 into x plus 3. Then I have a minus sign between. Then x plus 1 cancels out with x plus 1. I'm left with x minus 3. This will be multiplied with x minus 1. So x minus 3 times x minus 1. Okay. Now, I'm going to expand this one first. X times x is x squared. And then x times 3 is 3x. And then 1 times x is x. And 1 times 3 is 3. I'm going to put the minus sign here. All right, I'm leave the minus sign here. And first, I'm going to expand it inside the brackets without letting this negative sign affect the values inside. So x times x is going to be x squared. X times minus 1 is minus 1x. Minus 3 times 3x is minus 3x. And minus 3 times minus 1 is plus 3. Okay, x minus 3 times x plus 1. Okay, now I'm going to open the bracket like this negative sign. X squared plus 3x plus x would be 4x plus 3 minus, now this is plus x squared. Once opening the brackets, this would be minus x squared. And this is minus 4x. Once I open the bracket, it will give me plus 4x. This is plus 3. Once open the bracket, this will be minus 3. X minus 3 times x plus 1. Okay, now x squared cancels out with x squared. Then I have 4x plus 4x as 8x. And then plus 3 minus 3 cancels out. So I'm left with nothing over x minus 3 times x plus 1. Looks like you both made a mistake in expansion. Did you get the first part as it is? The first part.
Yes, sir.
Okay, then definitely you have made a mistake in expansion. I hope you got your mistakes. Have you?
Yeah.
Okay.
Yes.
So this is your final answer. 8x over x minus 3. These are very easy questions. All you have to do is You need to be very good in expansion and the factorization. That was the first things when we did when we started algebra. Okay. So ठीक है. Have a good day. See you all on Wednesday, inshallah. Take care. Allah Hafiz.
Thank you, sir.